Let's start with chapter 12 Sound. Sound waves. Sound is produced when an object vibrates. These vibrations make particles in the surrounding medium, air, liquid, or solid, move back and forth. Key points here are sound waves are longitudinal waves. They require a medium to travel through. Sound cannot travel in a vacuum because there is no particles to vibrate. When a sound wave hits a solid, the changes in pressure makes the solid vibrate too. Example, a loud sound can make a glass vibrate and break. Representing longitudinal waves are shown as region where particles are close together, which is called as compression, and far apart called as rarefactions. Compressions and rarefactions: compression region of higher pressure and particle density, rarefaction region of lower pressure and particle density. Sound is therefore a pressure wave. Pressure rises and falls as the wave passes. When sound strikes a solid surface, these pressure changes make the surface vibrate in step with the sound wave. Measuring the speed of sound. Speed of sound depends on the medium. In air, about 330 to 350 meter per second, faster in warmer airs. In liquid, around 1500 meter per second. In solids, around 5000 meter per second. Sound travels fastest in solids and slowest in gases. Equipment used in speed of sound experiment. Treadle wheel or tape measures measure distance. Wooden blocks make a loud sound. Stopwatch measure travel time. Oscilloscope and microphones extended show sound signal accurately. Experiment number 1: measuring speed of sound between two people. Aim: measure the speed of sound in air. Method overview: measure a distance, example 100 meter, between two people. Person A bangs wooden blocks above their head. Person B starts the stopwatch when they see the block hit and stops when they hear the sound. Repeat several times and find the average time. Try different distances like 120 meters, 140, 160, etc. Speed is calculated from speed is equals to distance divided by time. Result should be close to 340 meter per second. Experiment number 2: using an oscilloscope. Aim: measure time delay more precisely. Method overview: two microphones are set a few meters apart and connected to an oscilloscope. A loud clap is made near microphone 1. The oscilloscope shows when each microphone detects the sound. The time difference between two signals is measured. Repeat using different distances. Again, try the formula: speed is equals to distance divided by time. Evaluation of experiment. Experiment 1 is less accurate. Reaction time affects stopwatch result. Sound travel time is very short. Timing error is large. Experiment number 2 is more accurate because timing is recorded electronically. To improve accuracy, use large distances so time is longer. Take repeat readings and average them. Effects of sound wave. Pitch and loudness. Frequency determines pitch. High frequency, high pitch sound. Low frequency, low pitch sound. Amplitude determines volume. Large amplitude, large sound. Small amplitude, quiet sound. Let's talk about echoes. Sound waves reflect off hard surfaces. The reflected sound is an echo. The distance to the reflecting surface can be calculated from the formula: distance is equals to half time speed time time. Half is used because time measured includes the sound traveling there and back. Ultrasound Humans hear sounds between 20 Hz to 20,000 Hz. Hearing range decreases as we age. Ultrasound, frequency above 20 kHz. Uses of ultrasound medical imaging, example fetal scans. Checking for cracks inside material, industrial testing. Sonar underwater measuring depth or detecting fish objects. How ultrasound works. When ultrasound reaches a boundary between two materials, some of the sound is reflected, some continues through. A transducer emits ultrasound pulse, receives reflected signals, shows them on an oscilloscope. Depth can be found using depth is equals to half time speed times time. Industry. Material testing. Ultrasound pulses reflect sooner if there is crack inside metal. On the oscilloscope, extra pulses appear earlier than expected. Engineers can locate structural faults. In medicine, used for imaging soft tissues like organs and fetuses, safe and non invasive, no ionizing radiation, also used in treatments such as breaking kidney stones. Ultrasound underwater sonar, sound pulse travels to the seabed and back, time measured, depth calculated using the same formula. Worked example, a steel bolt is tested using ultrasound. Time between emission and returning echoes is equals to 5 divisions. Each division is equals to 0.000002 seconds. Speed of the sound in steel is 6000 meter per second. So time that is given 5 division, we will multiply time with each division and we will get the time. Then for total distance, our formula is speed times time. So we will multiply and we'll get our distance in meters. Then we have distance to crack, which is 0.06 divided by 2, and it also gives us the distance in meters. When we convert this to centimeter, our distance will come to 3 centimeter. So the crack is 3 centimeter from head of the bolt.